Welcome to Electrostatics and Graphs. I'm Ennemcien. Let us see the graphical variations of physical quantities. I have discussed it earlier in some plastics. Yet I introduce the essential points. Two axes are required to plot a graph. You know it. One is horizontal axis, the other is the vertical axis. Sometimes we call the horizontal axis as the x-axis and the vertical axis as the y-axis. Let us call them as the horizontal axis and vertical axis. The quantity which we plot along the horizontal axis, we call it as H, capital H. And the quantity which we plot along the vertical axis, we call it as V, horizontal, vertical. If the two quantities are related like this, say V equals Kh, where K is a constant, definitely the graph will be a straight line. The slope of that graph is the factor K, constant K. So to find out slope, just you divide quantity on the vertical axis by quantity on the horizontal axis, that is V by H. You will get the slope of the graph. For example, if you draw velocity time graph and divide the vertical quantity velocity by the horizontal quantity on the horizontal axis t, we get v by t, velocity by time. That represents acceleration. Now, to find out the quantity represented by area under the graph, just you multiply the two quantities and then you decide which is the quantity. So for example, this is a graph of two particles or two body objects in translational motion. Here the horizontal time is plotted on the horizontal axis. Acceleration is plotted on the vertical axis. Here the two graph lines are parallel to the vertical axis, that horizontal axis. That means vertical quantity remains constant or acceleration is constant here. Moreover, this is at a higher position. Graph A is at a higher position. That means acceleration of body A is greater than acceleration of body B, or A1 is greater than A2. With this graph, if you are asked to draw velocity time graph, you have this equation V equals U plus AT. If the body starts from rest, of course it can start from rest with the constant acceleration itself, and it can maintain the same acceleration throughout the motion. The slope of this velocity time graph, that is V by t, must represent acceleration. So the graph we are going to draw, that is velocity time graph, must have a slope of acceleration. So the graph here, accelerations are A1 and A2, and A1 is greater than A2. That means, and the two particles start from rest. So slope of A must be greater than slope of B. So the two graph lines, velocity time graph lines, must be straight line like this. A with higher slope, B with lower slope. Then another case, if the equation is V equals KH plus C, this also represents a straight line which starts from a point at a height C from the origin. This is called y-intercept of the graph. Say like this. If the equation is of the form V equals K by H, this represents a rectangular hyperbola like this. The curve is symmetrical about the two axes, or the graph lines tends to be parallel to the two axes. As we move up, the graph is tending to be parallel to the vertical axis, and as we move towards this direction, the graph is going to be parallel with the horizontal axis. That is rectangular hyperbola. So this equation is V equals a constant by H. If V equals K by H square, still the graph is a curve which is more steeper than this. Is more steeper like this. This is a curve without any particular name, but it is steeper. It is more vertical and bends like this. See this. If the equation is V equals K H square, then the equation is a parabola starting from the origin, because at the origin h equals 0, that means v equals 0. The graph starts from origin, so this equation represents a parabola starting from the origin. If v equals c minus kh square, the graph is still a parabola whose vertex is at a height c from the origin. Now these essentials meet your requirements for exams. With these points, we will discuss variations of electric field or potential, etc. in the coming section. So electric intensity due to a point charge is given by E equals 1 by 4 pi epsilon 0 into Q by R square. 1 by 4 pi epsilon 0 is a constant. Suppose you are asked to draw a graph between intensity and charge. That is, you have to study variation of intensity at a particular point caused by changes in charge. You place different charges, or you use different field creating charge and study the intensity at a particular point and draw a graph. So here, quantity on the horizontal axis is the charge. Quantity on the vertical axis is the intensity. Here the basic equation is this. So here H is Q, V is E, R is a constant, 4 pi epsilon 0 is also a constant. That means 1 by 4 pi epsilon 0 R square. Let it be the K value, constant. So here this equation takes the form V equals KH. V equals KH. H is Q and V is E. So this represents a straight line starting from the origin. This is the graph. Then Another point, you have to find the variation of intensity with the distance. So you plot r square on the horizontal axis, E on the vertical axis. Here Q is a constant. So this equation becomes E equals, E is, V is E and H is R square. H is R square, V is E. So this, now our present equation takes the form V equals a constant K by H square. K by H, I'm sorry, R square is H. Here H is R square. So you put H in the place of R square. These things are constants, K. So V equals K by H. V equals K by H. That represents a rectangular hyperbola. That means E R square graph is a rectangular hyperbola. Another point, let us draw a graph between E and R. Case is the same. E equals 1 by 4 pi epsilon 0 into Q by R square. Here V equals E, H equals R. So our intensity equation, here the intensity equation becomes V equals K by H square, because V is E and H is R. So here in this equation, you put H in the place of R. So you get V equals K by H square. So what is the nature of the graph? That is a curve steeper than hyperbola. Another case, you draw a graph between E and 1 by R square. 1 by R square, you put it as H. So here H is 1 by R square and V is E. So V equals K into 1 by R square. 1 by R square is H. That means V equals KH. This same equation takes the form V equals KH because 1 by R square is taken as H. So what is the nature of the graph? There's a straight line. V equals KH. Graph is a straight line. Another case, E and 1 by R. So you put 1 by R as H. So 1 by R square is H square. Now this equation takes the form V equals KH square. KH square is the equation of parabola starting from the origin. So for the same formula, we can have different forms of graphs. We will see such questions, this type of questions again. Thank you.